Welcome to Maths with EJD. In this video, we'll be talking about the PGF of the geometric distribution. That's the probability generating function that's under the playlist for generating functions. So we've looked at the PGF of Bernoulli distribution, Poisson distribution. Now we're looking at that of geometric distribution. So the geometric distribution is so-called It is called geometric distribution, right? Because its probabilities, its probabilities follow a geometric sequence. Okay, that's why it's called geometric distribution. Now, having said that, for a geometric random variable, for a geometric random variable, x with success probability p, the probability mass function PMF is so the probability mass function is that which generates the probability, right? Yeah, is how the probability is arrived at, right? So the PMF is P, probability that X is equal to K is actually 1 minus P raised by K minus 1 multiplied by P. Okay, here K is from 1 to 3 and so on and so forth. So, and we generally know that to get the probability generating function, all we need is this P because so now we can move ahead now and find the and try to find so to find the PGF, to find the probability generating function, to find the probability generating function, which is PGF, right? So we have, okay, I guess I have to write that at the top. So we have GXS to be summation from x equals 0 to infinity of the probability at x multiplied by s raised to power x. Okay. And now to get all this, so that's more like we have P0 S0 plus P1 S1 plus P2 S2 plus P3 S3 and so on and so forth. Now, how do we get all these P's? That's the issue. So those P's we can get from the PMF, which we have been given. So to obtain P0, P1, P2, P3, and so on and so forth. So we go for the PMF, where we have the probability that x is equal to k is simply the same thing as 1 minus p raised by k minus 1 multiplied by that p, knowing that k, right? K has to start from 1. So 1, 2, 3, and so on and so forth. So in this case, you see, since k starts from 1, we have to um so we have to start from 1, right? So in that case, we have, so this P naught, I don't know, maybe it can take a value of 1 or something, but let's see how that goes first. So now we have probability that x is equal to 1. That's when k is 1 now. So we have 1 minus p raised to power 1 minus 1, that's 0p. And that's simply 1 minus p raised to power 0, that's 1. So this is simply p on its own. And then next we have p, probability that x is equal to 2, meaning that k is 2 now. So we have 1 minus p raised to power 2 minus 1, that's 1 raised to power p. So that's more like we have p into 1 minus p. Okay. So next, we have probability that x is equal to 3. That means k is 3. And that means we have 1 minus p raised to power 3 minus 1, that's 2p. So that's p into 1 minus p squared. So, I mean, we have seen the pattern already. So this is more like what we can call, this is more like our p1, p2, and P3, and so on and so forth. So we have seen the pattern. In fact, if we stretch it further, we just know it's going to be 1 minus P just increasing. So here we have P now equals X raised to power 4. That means we have 1 minus P raised to power 4 minus 1, that's 3P. So that's P into 1 minus P raised to power 3. And that implies that that is our P4, right? This is our P4. So if we bring back the formula, and now knowing that we can only start from 1, so we can say therefore GXS is summation from x equals 1 to infinity for PXSX. Okay, so as a result of that, we have P1S1 plus P2S2 plus P3S3 plus all that. So what is P1? P1 is simply P. Okay, so that means we have PS plus P2 is P into 1 minus P. So we have PS into 1 minus P, or better still, P into 1 minus P S squared plus P into 1 minus P, all right, 1 minus P squared, um, okay, P into 1 minus P S squared plus P into 1 minus P, 1 minus P S cube, and so on and so forth. So now we can see that this already has a pattern it is following. So the sum to infinity, right? If you try to do sum to infinity for this now, we can see that gx of s, if I can change this now. So we basically see here that gx of s now follows. So there's a pattern. So it's 1 minus p times s. So we have a common ratio. This is the first term, ps. Together, the next term we multiply by 1 minus ps. Together, the next term we get 1 minus ps. So it's more like the common ratio is 1 minus p times s. So the first term is ps, all right? The first term is ps, and then this is all over. The first term is ps, right? And this is all over 1 minus 1 minus 1 minus ps. Yes, that's how that goes. Um, yep. Or better still, if we take out all the s's, does it make any difference? Okay, so at the end of the day, right, we're going to have p all over 1 minus 1 minus ps. So if we take it if we do the sum to infinity, p all over 1 minus 1 minus ps. So this is the probability generating function for that, for geometric distribution. Okay, so let's take an example to drive the point home. So let x be a geometric random variable a geometric random variable with p equals 0.3. Okay, find the probability generating function of x. Okay, so the solution is simple. We just have our, gx of s is actually p over 1 minus 1 minus p multiplied by s. So that means that gxs is equal to gxx is equal to p is already, p is 0.3. That's what we have been given. So that 0.3 all over 1 minus 0.3 s. So this is equal to 0.3 all over 1 minus 0.7 s. So now this is so the probability generating function is gxs equals 0.3 over 1 minus 0.7 s. 1 minus 0.7 s. And that is that. Okay. So this is what we have, basically. All right. So if I might give you some practice questions based on everything we've been doing before now, even the videos before now, practice questions. Calculate the first and second moments, of the following. Number one, Bernoulli function. So it means you get the probability generating function, and then you do all the, you differentiate, substitute one. Then the next one is Poisson. Oh, did I say Bernoulli function? Bernoulli distribution. Bernoulli distribution. We're talking about probability here. Bernoulli distribution. Okay. Then to Poisson distribution. Poisson distribution. Calculate the first and second moments of this. 3, geometric distribution. That's what we did in this video now. So you may have to refer to the previous videos, find out how to get the probability generating functions, and then you differentiate twice, and then put everything together to get the required results. So with this, we come to the end of this one, which is about the probability generating function for geometric distribution. If you have not subscribed to this channel, there's so much more still coming, so you don't want to miss out on anything. So subscribe to this channel, hit the notification bell so you can always get alerted each time a new video is released. Comment, let me know how helpful these videos are. And then, of course, comment, let me know if there's a topic you'd like me to teach or a problem you'd like me to solve. Like and share also, so that more people can have access to this great content. Till I come your way again, keep enjoying maths. Bye.